So we are in Chapter 2, Section 9, called for IM1, called Weighted Averages. So this is the end of Chapter 2. And weighted averages are pretty common, especially in school, but it happens in other places too. But this is found by multiplying each data value or data point by its weight and then finding the mean of the new set, data set. So this is, that's definitely a very mathematical definition of weighted average. We'll look at what that means in a minute. But this is often used in grade books. For example, MRA has a weighted grade book. Homework is worth 65% of your grade, and tests/quizzes are worth 35% of your grade. So, and that's still true right now, but we divide this up a little bit more. So homework is two pieces. We have topics, which is worth 10%, and the actual homework pages that we have in there that is worth, topics are 15%, not 10%, silly me, 15%. And then we have the actual homework pages that are worth 50%. So together, this is 65%. So that's still true this year. We just kind of divided up a little bit more. And then tests and quizzes are worth 35% of your grade. So right now we have quizzes, and that's worth 15%. And then we have tests, which are worth 20%. So together, 35% of your grade. So we've actually broken this up a little bit more than just the two categories. We've broken it into 4 categories. And so what it means is that you might do your topics and you get 100% for the week on topics. But really, we have 15 weeks in the semester that we give you topics for. So that really means that each week is worth 1%. That's actually kind of what it breaks down to, of your grade. So of the 100% of your grade, only 15 of those percentage points goes to topics. So it's not worth as much, of course, as this 50% of your grade. So of the 100%, 50 of those percentage points goes just to doing the homework. So it just means that each piece is worth a little bit more or less than the other pieces. And definitely, makes this homework piece quite a bit more important for completing. But if you only completed homework, even if you completed all of your homework at 100%, you got 100% on every single one, you'd still only have 50% in the class because it's only worth 50% of the class. So it's one of those things to understand weighted average, but we've talked about this, I know in my class a few times, as far as how the grade book is set up. So we use this quite a lot in school for weighted averages, but we also use it in other places too, and we're going to look at combination problems or mixture problems. So this is a problem in which 2 or more parts are combined into one whole. So let's take a look at an example here. We have this mixture problem, and I like to set up a little table like this. You don't have to have, the color coding or anything, and sometimes we just have mixture 1, mixture 2 instead of these actual names, but that's okay. So in this mixture problem, we have coffee. How many pounds of premium coffee beans, should be mixed with 2 pounds of supreme coffee to make the blend coffee? So this would be mix 1, this would be mixture 2, and this is the total. So this is the end result. We're mixing premium and supreme to get the blend. Okay, they just all have names in this one, so sometimes they don't have names. And sometimes it's just a percentage or something like that is the name. I've come across that quite a few times. So in this problem, they don't really give us a lot of information, but they give us these visuals over here. So we know premium is $9.50 per pound. Supreme is $11.75 per pound. And the blend they sell for $10 per pound. So the reason I like this little table, it helps us set it up so that we have the correct equations here. So for this one, we have price times the number of pounds you buy is going to be your cost. So we want to set this up for each one real quick. So I like to color code this, and I'll just leave this one blue. So I'm going to circle premium in blue, and I'm going to write that across here. So we know the price is $9.50. I don't know how many pounds I'm doing. So it says how many pounds of premium. So how many pounds of premium is what we're trying to answer. So that's my question mark, okay? Instead of question mark, though, I think what I'll go with is P for pounds, okay? and then that's multiplied together. So I multiply together and I get my cost, which is $9.50 per pound, or just 9.50p. So the next piece, I'll do this in red, why not? We have Supreme. So Supreme costs $11.75 per pound. Remember, they told us that already. And we know how many pounds we're using. It told us we're using 2 pounds of Supreme coffee. So 2 pounds. I'm going to multiply, and I'm going to put this over here. So we have $11.75 times 2, and I get $23.50. And yes, you can use a calculator for that if you would like to. You could also do 11 times 11 is 22. 75 cents plus 75 cents would get us $1.50, and then I can add those together so you can kind of separate them out in your head if that makes sense, you know, doing that mental math. All right, I have my 2 pieces here. So my last piece is to do premium, and I'll do that in kind of this pink color. Sorry, not premium, blend. Ha ha ha. Blend. We know they sell that for $10 per pound. We don't necessarily know how many it's going to make because we don't know how many pounds here. So this is one where to know how many pounds are going to be in the blend mixture, we need to bring this down. So it's P plus 2. P plus 2 more. Because we know we're using 2 pounds for sure of Supreme. I don't necessarily know how many pounds of premium I'm using. That's what I'm trying to figure out. And then the cost is actually also going to be these 2 pieces brought down. Okay, so it's going to be the 9.50p, however many pounds I'm using for this piece, plus the $23.50 it's costing me to use the Supreme, the 2 pounds of Supreme. So it's going to be 9.50p plus $23.50. So what I like about this table is I've just set up my equation. This is the equation I need to solve. So that's a big reason I like this table, is it helps me set it up. Instead of having to picture all of this, I can fill in the blanks here, and I just have to know in the total area, you're always going to bring down 2 of the totals and kind of combine them this way. So remember, this is going to be kind of parentheses, and this is a 2, not a z. I know, I've been told my 2's and my z's look pretty much the same. So it's $10, and I'm going to drop off the decimals for now because we just don't need them, equals 9.50p plus $23.50. So I'm just rewriting this down here so we can see it. So the first thing I need to do is start simplifying both sides. This side is already simplified, the right side. There's no more parentheses, there's no exponents. I can't multiply here because it's a coefficient or a number times a variable, so I have to wait. And I can't add the $23.50 yet because I can't add unlike terms. I do have to simplify the left side. So I want to distribute this $10 and go 10p, 10 times p is 10p, plus 10 times 2, and that's 20, equals, and I'm just going to write this side down, boo, 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 $23.50. Okay. So now I want to start kind of consolidating this a little bit. I have a variable on both sides. I have a constant on both sides, because here's my variable on both sides. Here's my constant on both sides. I need to start bringing these like terms together so that I can get p all by itself. So first, I'm going to do this one. And I like doing this one because when I subtract 950 over to this side, I'm going to end up with a positive number. So it's just preference. I like positive numbers. Could you have subtracted 10 from both sides? Sure. You would just end up with a negative number. It's not really going to change the problem because it would end up kind of evening itself out. Whoops. Like that. All right, so $10 minus $9.50. So I can do that one pretty easily in my head. That's 50 cents left over. P plus 20 just comes down because I haven't done anything with it. 950p minus 950p, that cancels. So we have 23.50, and I'm scooching that one over just so that it's not too far away. I'm going to now move the 20 over to the right side. So it's being added. I'm going to subtract. Boop. And we end up with 0.50p. The 20s cancel. And we have 3.50 left over if I take the 20 away from 23.50. All right, the last thing I want to do, this is being multiplied by 50 cents, so I want to divide by 50 cents. I know I'm getting right down to the bottom here. 50 cents. So 50 cents divided by 50 cents cancels. And I'm going to write it over here. So P equals, so with this one I just want to know how many 50 cents are in here. So if you think about that, I know there's 2 for each dollar. So there'll be 2, 4, 6. And then there's a 7th one here. So I know that's going to be 7. So I kind of did that in my head there, you know, quickly. But you could also just do this on calculator, you know, 350 divided by 0.5. That's perfectly fine. You'll still get 7. But you can kind of do that mental math if you think about what you're being asked to find. So P equals 7. What does that mean? We need to make sure we explain it. We need to use 7 pounds of the premium coffee to get a $10 blend. And actually, I should even throw in here, oops, spelling blend wrong. Don't know what I'm spelling there. Blend. And we should even say 7 pounds of the premium coffee with 2 pounds of the premium coffee to get a $10 blend mix. So we're just explaining when we use the words there, what does this actually mean? So I know mixture problems can be a little bit scary sometimes because it feels like it has a lot of steps. There's not a whole lot of information up here, but just with this information they've given me, I can build this equation. So again, I really like these tables just because it helps me lay it out very clearly. These are all the pieces I have, and if I put them together, I can solve this equation. All right, so that was section 9, and I will see you in chapter 3.